Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how to calculate the probabilities for independent events and dependent events and how they affect one another. So independent events, remember, they don't affect each other. So what that means is the probabilities don't change when the events occur. So the way that we calculate those probabilities are the probability of A occurring and B occurring, if A and B are independent, is going to be the probability of A times the probability of B. Now, that's super important. The word and, remember, means to multiply. And it's always going to mean that. So anytime we see the word and, we are going to multiply. Now, that when they're independent events, we just multiply their probabilities. What's the chance of getting heads? Times what's the chance of getting heads? There we go. Dependent events are ones that affect each other. Because they affect each other, what we have to do is we have to take into something called conditional probability. So what conditional probability says is we're going to look at the probability something happens if something else has happened prior to it. And dependent events, because they affect each other, we have to take into account what's happened prior to. So if we are looking for the probability, let me scroll down here. The probability of getting A and B occurring if they're dependent events. What we're going to do is we want to find the probability of A occurring first times the probability of B occurring, but B has to occur given, that's what this line means here, is given that A happened first. And so take, for example, us drawing a card, and I want to know what's the probability of getting hearts and then getting hearts again. So these are dependent events because I'm going to do this without replacement. So I'm going to take a card, set it aside, take a card, and do it again. So the probability of me getting hearts the first time is going to be 13 out of 52. And means multiply. And then I want the probability of getting hearts given that I got hearts last time. So if I got hearts last time, there are only 12 hearts left and only 51 cards. Now we find this conditional probability all the time in our minds. We see it whenever something is taken out and we're not replacing it. We have that conditional probability. Now that conditional probability plays a huge role in dependent events because we have to have that event occur prior to doing our calculations. So let's take a look at some examples of independent versus dependent events and how we would change in their calculations. So in this first one, you have 2 quarters and 3 dimes in your pocket. We're going to remove a coin, put it back, and then get another. Is this an independent event or a dependent event? Well, I'm going to remove a coin, put it back, and then pull out another one. Did the number of outcomes change, or was there any effect on what coins I had to choose from if I pulled a coin out, put it back, and took another one out? No, they don't affect each other, the probability. So these are independent events. So the probability of getting a quarter the first time and then getting a quarter the next time when they're independent is the same as the probability of getting a quarter times the probability of getting a quarter. So the probability of getting a quarter the first time is 2/5 times the probability of getting a quarter the second time is 2/5. So that's going to be 4/25. Great. Okay, this time we're going to remove one and then remove another. So because we removed one and didn't put it back, what happens the second time is affected by what happens the first time. So these are dependent. So remember, when we calculate something dependent, we have the probability of getting a quarter times the probability of getting a quarter given that we got a quarter last time. So what's the probability of getting a quarter the first time? Well, it's still 2 out of 5. And we're going to multiply that times the probability of getting a quarter if we already got a quarter last time. So if we already got a quarter last time, we have 1 quarter left and there are only 4 coins left in our pocket. So this is going to be a 2 out of 20 instead of a 4 out of 25 because this condition on us getting a quarter, if a quarter was already chosen, has to play a role there. So that's really how that conditional probability and independent and dependent calculations are affected. So let's take a look here at this next one. We said it was independent in the last video. So what I want to do is find the probability that we get a 5 on my first spin and a number greater than 3 on my second spin. Okay, so the probability of getting 5 and then a number greater than 3. Okay, so the probability of getting 5 times, because they're independent, that's going to be the probability of getting something greater than 3. So the probability of getting a 5 is 1 out of 8 times the probability of getting 3. Well, some number greater than 3. Well, that's 1, 2, 3, 4, 5 numbers greater than 3. So 5 times 8 will give us a 5 out of 64. And we can leave that there. We can also calculate it into a decimal, and that would give us a 0.078, which is approximately 7.8%. So the probability of me getting a 5 and then a number bigger than 3 is about 7%. Okay, so let's take a look at these next two, or at this next one here. So you randomly select 3 cards from a standard deck of 52 playing cards. What's the probability that all 3 cards are hearts when you A, replace before selecting that card, and B, do not replace? So A, when we replace it, that means that the events are going to not affect each other. So these are independent. So when we find independent events, remember, we're just going to take the probability of getting a heart and another heart and another heart. But because they're independent, that means it's the probability of getting a heart times the probability of getting a heart times the probability of getting a heart. Okay, and that's going to be 13 out of 52 times 13 out of 52 times 13 out of 52. Now this turns into 1 over 64, which is going to be approximately 1.6%. Then if we look at our other event, what part B says is, what's the chance of getting 3 cards that are hearts when we don't replace it? Now, if we don't replace it, that means they affect each other. So this is actually going to be a dependent problem. And this dependent problem means that I'm getting the probability of a heart. It looks the same, and then another heart, and then another heart. The only difference is that now I'm looking at the probability of getting a heart times the probability of getting a heart given I got a heart last time, times the probability of getting a heart given that I got a heart the time before, that I got a heart and a heart given a heart. So, oh my goodness, look at all those givens. So that looks really complicated, but really what it's saying is, what's the chance of getting a heart the first time? 13 out of 52. Times the chance that we get it given that we got one the first time. So now there's only 51 cards left and there's only 12 hearts. So we only have a 12 heart chance. This last one is saying the probability of getting a heart given that this event occurred. Well, if this event occurred, there are only 11 hearts left and only 50 cards that we can choose from. And this one is going to be some obnoxious big fraction number here that ultimately comes down to being about 1.3%. So really the difference between these two is not huge, but the calculations play a huge role in it because they're not independent events. In part B, they are dependent. So with that being said, independent and dependent probabilities are so important. And again, they are calculated just a little bit differently. So independent events, again, are going to be just the probability of the first event happening times the probability of the second event happening. When they're dependent, then it's the probability of the first event happening times the probability of the second event happening, given that the first one did happen. We have to assume that when they're dependent events. Please check out the next video in how we look a little bit more at conditional probabilities and how conditional probability affects a problem.